right, we're back. So welcome to our stream today. This is the first time we're actually doing a shared stream. So I have with me 𝗥𝗲𝗃𝗃. He is one of our developer advocates as well. We both work at Timescale as developer advocates. And we're going to talk about TSBS. It's one of those things that the time series benchmarking suite that we get a lot of questions about. And we realize that as it's used more and more throughout throughout the community, it's, more and more time series databases are coming to fruition. We're glad that this tool is available. We use it. A lot of other time series databases use it to get a sense of, where we, how we compare for different use cases in different scenarios, what that might look like. As we say in every benchmarking post we do, and I appreciate that so many of our fellow time series database companies do the same, benchmarking is really hard. This is a made-up program that generates fake data to try and simulate load, and it's not perfect. It currently does things just in one direction, right? You do insert and ingest. We're going to talk about that in a minute, and then query separately. There's a lot of places this can go, but there is value in what it provides across the board as we talk about time series data. So, Jonatas, what have you been? You've been playing with TSBS and the code quite a bit lately. So, what are your thoughts at this point?
So TSBS is great, and it's a full engine to test like 10 plus databases. I guess it's 12 actually, and this is very interesting. I am plugging Timescale now into it, so we can have like a full observability of the machines that they're running. So I'm very excited about it, and also I'm very excited because I was testing even TSBS running on my Raspberry Pi, and it was very funny because I can collect and check results in even smaller machines. So Go is pretty portable, and you can run it everywhere.
That's great. Well, so let's go ahead and talk. We are a few minutes after 10 and just go through. So here's what we're going to do today. This is really the first in probably 4 or 5, maybe 3, 4, 5 streams about benchmarking in general. So it's something we do a lot of. Obviously, you've seen that if you follow Timescale at all. We have a number of blog posts. I'll pull one up briefly. That we have referred to often. So, we have benchmarks based on Influx and Mongo and others. And that's just over time, we're trying to answer our own questions. We're trying to answer user questions. And so that's really one of the ways that we use this. And so as you see these benchmarking posts, recognize that this is the tool we're using. And we're continuing to make updates to it. And we're going to talk about that in future posts. So this is going to be an intro. What is the time series benchmarking suite? And how do you use it? Just basic usage. How do you generate data, insert data, generate queries, and then run the queries against the database? We're going to use Timescale. It's a setup we have currently in our environment. It's, we've been using it for other things. So to be quite honest with you, I'm not 100% sure the state of it from a performance perspective. We've been tweaking various things and testing, but we're going to show you how to do all that. And then in a couple future streams, we're actually going to do a larger benchmark of Timescale, show you how we do it as we release new versions, the kinds of things we're looking for, both potentially any regressions, areas that it's gotten better. Things like, one thing that we saw, for instance, with Postgres 13 is that we could insert a significant amount of data quickly with TSBS, enable compression, and compare Postgres 12 to Postgres 13. And if you know anything about Postgres 13, one of the features was deduplication of indexes. And it turns out with Timescale DB compression, not only do you get significant savings with our compression in column or storage, but because of index deduplication and how we store the data, we actually got even more compression. You saved even more data in Postgres 13, and we could see that with much more quickly with the time series benchmarking suite. So that would be a future stream. And then we're actually going to benchmark 2 databases together in another stream. There's 1 or 2 databases we've been looking at recently, trying to understand them better. And so probably we'll go along with a blog post that's due out soon, and we'll actually benchmark Timescale and one of those databases. Walk you through our process. Again, we recognize, I'm looking at Jonas. I know he feels the same way. This is not perfect, right? We're trying our best to understand more and more, and we're adding. This is an active development and something we're going to talk about. So let's talk about time series benchmarking suite. So here's what we're going to do today. I've already mentioned it, what it is, supported databases and use cases, which I'll let Jonas cover a little bit. Installing it, we're just going to look at it. We're not actually going to install because we already have something set up and the instructions are there. It is a Go program, so we'll talk about that. We'll generate data, load data quickly, and then run a few queries to get you through the process. And talk about some of the gotchas along the way or things that you can be aware of to kind of change your benchmarking. So first, what is TSBS? Jonas, what do you have to say?
Okay, so if you think about when you need to test a scenario and compare it to a multi-database, it's very hard. So you need to set up tables, set up some data generator to ingest data and then queries. So what we did at Timescale was organizing it and allowing people to expand it to another database. So we received contributions from all these databases, like core team from our other databases are also using it to check where they are and how they are performing. So we have very interesting scenarios like IoT, DevOps, and some finance scenarios. And some of the databases, they are accomplishing to all the scenarios. Some of them are partial. And this is interesting because you can reuse the same parameters. So let's say, for example, you wanted to test like, oh, I have 100 devices and they are emitting signals every second. So I need to see how my server would behave if I have like 1 year of data, or how much workload this server can hold. And TSBS can be very useful for it. And then you can just switch what is the adapter, in this case, like what's the database, and then you can test the same scenario, the same amount of data in another database. So it's full of details. Our implementation are slightly different, but they have the same data structure, and the queries are, let's say, very common queries that you run. So you test both data ingestion and queries.
All right, so I'm just talking with the team. It looks like seems to be a continued issue. So we use a streaming service called Restream to allow us to do this to multiple services. And testing ahead of time, we did not have the issues we expected with computer sound, but that seems to be an issue right now. And so this is one of the problems with trying to test yourself and stream. So streaming to my account individually was a little bit better. And unfortunately, at the moment, I do not have headphones sitting next to me, so I cannot change this immediately. So I need to figure that out. So I'm guessing when I mute Jonas at the moment, that probably is better. Is that true, Miranda? I just muted him. Are you still getting feedback? All right, bear with us for a moment. I'm going to have to, yeah, this did not happen earlier. Seems to be the case with just about everything when we're streaming together. All right, apologize. We are just trying to figure out what's happening here with audio and this is okay. So when he was speaking, so it sounds like as long as he's muted for the moment, it's a little bit better, and I can tell why that is. I think I'm not honestly sure why that is. I'll have to play with that as we go. So I can flip back and forth as needed. So right now, Jon-Tas, I will mute you on and off. Exactly. I'll just make sure I'm muted here. So, all right, time series benchmarking suite. So I'm going to mute myself to talk about the various use cases that Jon-Tas will work through before we get to some other stuff. Go ahead, Jon.
Okay, so the first thing that you need to think about benchmarking is that you are going to test the limits of the machine. So depending on what you are going to try to ingest, you are going to see different limitations in, and this is the interesting part of reusing this Go application to build it. So one of the most interesting params we can have there is like a parallel. So we can set like a minus workers to set up multiple parallel loads or multiple parallel queries. And we also have a data load that is divided into two main mechanisms. One is like you generate data in advance and just load the data from a single file. And the other is like a online simulator. So you can just create data in memory and flush it to the database. So these options are, let's say, important depending on what you are doing. So for example, the simulator in a very humble hardware like a Raspberry Pi, it consumes like 30% of the IO and everything. So it will degrade like 30% of the benchmark because you are doing this. And another important aspect is like you using two different machines, one to generate data and other to host the database and make the workload through there. So if you are on localhost, it's easy to make it. But if you are on a cloud system, probably you also need to set up a VPC between the machines and everything. But it's worth to make it because the network will really become like the main constraint of your benchmark. So every time you let's say get free from a constraint, you fall down into another. So that's the interesting part of benchmarking. So one time it's on the IO, one time it's on the network, and so on.
That's great. So yeah, that's what we're going to work through is how to load it into each of these. And so as Jon-Tas said earlier, and we were having some issues with feedback, so I just want to reiterate, this is this is a GitHub project. It's open source. You are welcome to contribute. You're welcome to look at the source. I'm going to show you something in a few minutes. These are currently the databases that are supported with TSBS. And most of these are community contributed, right? So either the specific database company, whether it's Crate or ClickHouse or someone like that, their staff, their engineers have contributed to this. In some cases, it's actually been community driven. And so you can follow can download the source. You can create a pull request to add more functionality. Things that we've worked on recently, for instance, because it's open source and it's in the open. One of the things we're going to show in a future stream is how to see actually using something like Prometheus and Timescale to benchmark both the time series database, time series benchmarking suite client, resources that are being used, the ingest rate, things like that, and the database server itself. So we can see as the various processes are happening, how each computer reacts. And that was something that was not built into TSBS, but over the last couple of months, something Jon-Tas actually has been working on. And so that will eventually become something you can do with TSBS. So a lot that we can do, a lot that we can have there, and just exciting to see. So the use cases, what I wanted to talk about next is just what is possible. So supported databases and use cases. And let me go up here. So as we show on the website, we have 3 different use cases that are really meant to show a couple of different things. So the first one was what we call the DevOps use case. And the DevOps use case in general generates a set of things. We call them tags, and I'll explain that in a minute. It's a table that represents the device in this case. And so with DevOps, it's fake computers, right? So it's like VMs in a cloud. We just name them host 1, host 2, host 3, and so forth. And for each of those hosts, if you do the DevOps use case, it actually generates, I think it's 9 or 10 tables. Actually, at the moment, I forget exactly how many. And each table then has generated data for each of those things that we're monitoring. So for instance, it might be, CPU. So we generate 10 different values about CPU. It might be network, and we generate 10 different fake values about network, things like that. So that can be useful to see kind of scale and just have a lot of data across many tables. The nice thing about the DevOps use case, and specifically we're going to talk about the CPU only use case in a second, is that it's in even values, right? I believe there's 10 metrics per table. And so it's easy to calculate how many total metrics you're going to get based on your scale and some other factors. So we're going to talk about that. The Internet of Things use case then is a newer use case. It was created about 2 years ago. I would say this is still an in-process use case. It is actually fun to play with and see. It generates data for a fake truck company. And so it will, again, generate a Latin long, but of course those are not constrained to any area, so it just kind of moves all over the globe or all over at least a constrained area, but it's not an actual track or path. Temperature, there's 2 different tables that measure the values of each truck. The neat thing with this one is that it actually does try and mimic a more real-life scenario where not every truck reports all the time, not all the data is generated all the time for each reporting period, and so forth. So that can be very useful just to get a better sense of load and spread. And then what's not noted here, and so I said that, but we don't have it, and we've talked about this recently. Within the DevOps use case, there's actually a 3rd use case, and it is the CPU only use case. And that is what we generally use for benchmarks. It's what most of the other databases use for benchmarks. And so that happens when you see a benchmark like this influx benchmark, and we go down to the performance, which is going to be down here. You'll notice that we probably mentioned it. If we don't, you can kind of get the sense. There it is, CPU only. And I restarted, so Demo Pro, my apologies. There we go. So the CPU only use case is what we use here. And the reason is this. It's just really easy to calculate exactly how much data is going to happen. It's 1 table, 10 columns, and then based on the number of devices, the length of the reporting period, and how frequently we create a measurement, it's really easy to do simple multiplication and get the total number of rows and metrics. That's really why we do it. And then all of the queries query the CPU table. So whether you do the DevOps or CPU only, the queries themselves for the DevOps use case queries the CPU table. And so that's what is available as far as the actual time series benchmarking suite and the use cases. You'll see we try and keep this up to date as people submit pull requests, what databases support which use case. And as you'd expect, almost everyone supports the DevOps use case because of that CPU only and that CPU table. All of the sample queries we have for that benchmark come out of that table. So that's why that is the first supported one for each system. Do you have anything else to add here, ท่as, with the use cases?
I was confused about the finance thing. I think we don't have a finance scenario there. I was thinking somehow we started implementing some finance scenarios, but it looks like it's not there. So just commenting.
All right. So that's the first set, and I don't know if there's any questions at this point, and I'm assuming there's not. So let's go ahead and talk about installing TSBS. So again, we're not going to do this on this stream, something we can do later, but as ท่as already mentioned, anywhere that supports Go, which is every computer that I know of. This is a Go program. And so we have the installation instructions here. It's pretty straightforward. You can download the source code and do it locally if you want. You can do a Go make locally, or you can do it through the Go path, through the Go get. And that will download the source, compile it for your local system. And as long as you have your Go path set, it's the way Go works. It installs these binaries into the Go path so that you can then actually go use them. And so it's really that straightforward. Many people do it. If you want to get, so this will obviously, if it's not clear, this will pull from the master branch. At this point, there are a few other branches in development. Some of them are long. We need to do some cleanup, quite honestly. For instance, I'm noticing there's still a multi-node branch here. That has actually recently been merged through another branch. We had to do some cleanup. And so you can test Timescale DB multi-node now with TSBS, but that branch is a little bit defunct. So if you create a branch, or maybe you get in conversation with us, you can see the branches that have been created for PRs and go from there. All right, so let's talk about actually creating data. So that's the first thing that happens. And we're going to use the, so I'm going to head on over to the server that we have. And just so I have a marker for later, I am going to do this so I can see generate data. When we put this on YouTube, I want to be able to clearly and quickly find this. So generating data. So really the way TSBS works is it has to generate some kind of fake data, right, for one of these use cases. And then it has to, you use that data to insert into your target database. And up until about a year ago, for the most part, you would pre-generate the data. So you would specify a beginning and an ending period and the use case you wanted to use, generate the data file, which would get pretty big depending on how much data you were generating, and then you would load the data out of that file. And that generally gives you the best performance, right? So as ฎ said, depending on your environment, if you're trying to do this on a Raspberry Pi, trying to load a high volume of data with 2 gigs of RAM or 4 gigs of RAM on a small ARM chip is not going to perform really, really well. You're not going to get your best ingest and query performance running the client on the same device and simulating data on the fly. And so pre-generating the data, most systems can read that data out very quickly. It's very low overhead. And that way it lets the Go program focus on shoving data into the database, whatever database that is. So to generate data, I will grab a few things out here. We'll talk about things that are important. We already talked about the use cases, and we talked about each of these, what's unique about each of them. I will talk about the IoT use case in a little bit when we just talk about running queries. It's some conversation that's come up recently, and when that isn't a great use case, and I'll talk about that in a little bit. And again, understanding the use case helps you decide quickly and fairly easily decide how much data is going to be created in the end. So that's helpful. Most of our current benchmarks insert 100 million rows of data for the CPU-only table. Since it has 10 columns, 100 million rows times 10 columns equals 1 billion metrics. And so that is a number, those are the numbers you'll see in our benchmarks. If I do we try and get to that point, somewhere around that point. So as we look at these next options, you'll see that using these helps you determine that. So the first, I just wanted to get out there. I'm going to show you the command in a second. TSBS was also generated so that you could generate the same data from run to run, so from iteration to iteration. So if you set a seed, essentially it guarantees that you'll get the same data every time you run this process if you're trying to keep things consistent. Scale is the number of devices you're generating data for. So again, if I go back to our TSBS influx post, because it has a good chart there, and I'll zoom in a little bit, see if we can get this. Oh, there we go. So you see that the number of devices is really scale. So if you have 100 devices, so scale of 100 will create 100 fake devices in whatever use case you're currently using. So if it's IoT, it's trucks. If it's DevOps or CPU only, it's hosts, right? So that's kind of what happens there. And then we have the start and end timestamps. Actually, timestamp start and end. I realize I just messed that up. So that is the range. So you do have to tell TSBS where it's going to begin and where it's going to end. And then the next value helps it decide how often to create a reading between those two periods. So the scale, 100 devices, times the range, start timestamp, end timestamp, times the log interval in seconds. You multiply all those together and you get a total number of rows. So it's fairly easy, hopefully, to kind of understand. In this case, we had 100 devices for 31 days, and we use the, so that's the range, and we use the CPU only. So we know that we're going to get 10 readings for 100 devices. If we do 10-second intervals, that's 6 readings per second, per minute per device. You multiply all that together and you end up with just over 100 million rows. I think when you do the math, it's like 103 million rows, something of that nature. So you can play with all of those up and down. And as you play with those up and down, you can decide and kind of mimic various scales and loads. Now, why is this important? One of the big reasons this is important, specifically number of devices, is not necessarily to create a lot more data. Every database reacts differently to cardinality. So cardinality is the unique gradations within the data that you're creating, right? So creating a table with 100 unique IDs that repeat over and over again, every minute, every whatever, will perform much differently than a table that has 1 million unique identifiers for the data, right? When you query now, indexes, if the database supports indexes, will work very differently. And so that's one of the reasons we often will run these kinds of scenarios. We always try and constrain it to about 100 million rows. And that's why you'll see the time range changes dramatically, right? We go from 31 days for 100 devices to minutes for 1 million or to 10 million devices. And that just helps us do a different set of understanding, right? How does an ingest work with high cardinality? How does querying work with high cardinality? Jon-Tas,
Just
A reminder about like number of devices versus interval. So they are inverse proportional, and if you reduce the interval or increase the number of devices, you can grab a coffee and go somewhere else while it generates or loads the data, because you can easily get like 6 hours, 10 hours running. So just to be aware of this. So we also have another param, I guess, when you are generating the data, you can set like a minus limit that will at least say, oh, well, if I put something wrong here, let's limit it to 1 billion rows or 1 million rows or whatever you want to test. Just one thing, like I see a lot when sometimes we try to limit our benchmarks to like 2 days, 4 days, or something that is quite small with this, let's say, large number of devices. But the application, after some time, it will behave very differently. So it's a very expensive benchmark to try to run, but it will also show things that you cannot see just running 100 million rows. So it's quite important to just remember, like, if you have a large scale, don't go with 2 or 3 days, that it's like just a fancy playground for the first 3 days of running it. So, and then later you get more and more things to look at.
Yeah, that's so true. And that will come in future streams. We've learned a lot as we've been benchmarking the actual machines with Prometheus. Exactly as Jon-Tas said, the more data that comes in over a longer period of time, you start to get, so with Timescale DB, it could be your chunk interval, might need to be, it helps you understand when you have this scale of data in your environment, what size the chunk might need to be to perform better based on your resources and things of that nature. So it's a really, really good point. So to Jon-Tas's point, let's head back over here. So log interval then is how often TSBS will generate a fake reading for every single device that you have asked us to generate for the scale. So if there's 100 devices and you have a log interval of 10 seconds, that means you'll get, for every device, 6 total rows or readings per minute, right? So every 10 seconds per minute, you'll get 6 readings. And if it's a CPU only use case, that is 1 row with 10 values in it. So you're actually getting not just 1 row, you're getting 10 metrics per 10 seconds. So 60 metrics per second per device. And you start doing that math and you'll start to see that it can really increase pretty quickly, as 𝗔𝗲𝗃 said. We're going to show you that in just a second. And then the format. So the format is which database is being tested. And you can find that within every database, what it should be. So if we go back to the time series benchmarking suite, one thing I'll show, here's the databases currently that we showed down below. And you can assume it's generally the database name is what most developers have made it. Every database does actually have, if you go into docs, there is, in fact, we link it from here. So, if I go into Cassandra supplemental docs, it will go over to the Cassandra specific page. If the developers who added this functionality wanted to add something into it, they would have that here. And so again, it usually references what the actual database, the database thing that you're trying to load is and so forth, and various tests there. So I'm going to work down through this how-to, and I just have to wait a second. My computer doing all of these various things is not enjoying itself so much at the moment, but we're getting there. All right, so we already talked about the use cases. We talked about installation. We talked about the basic parameters. And the first thing then you have to do is generate data. And so we're going to go ahead and I'll point out 2 things. The sample that we give pipes this into gzip. And we even say right below it, note we pipe the output into gzip to save space on disk. So you'll have to decide for your use case what matters given the resources you have. For instance, a generic general database for Timescale, a TSBS benchmark, if I generate that 100 million rows, in general, with these parameters, it tends to be, 𝗔𝗲𝗃, I believe we tap out around 27, 28 gigabytes, something of that nature, for a raw file. Right, so you have to decide, number one, you're going to incur more cost generating the data going into gzip, and you will incur some small cost unzipping it as you pipe it into, to ingest that data in the next step. So you'll have to figure that out, decide on your own how you want to do that, and go from there. So I'm going to take a sample of this and bring it over here. So I'm actually going to play with this. We were playing a little bit earlier. And I'm on, so this is a TSBS client machine we have inside of AWS. It's an EC2 instance. And we have Timescale DB on a separate EC2 instance. That would be probably the other thing I'd mention, is if you run TSBS on the same machine as the database, you have to really look at the load that each is putting on the server and the resources. It will impact how the database runs. And in fact, tell you what I'm going to do, just so I can see everything that's going on. I will drag this over here so you can see this as I do it. So I'm going to paste this in, and you'll see that for this, we're going to generate data for the CPU only use case. I did provide a seed, so if I were to run this over and over again, I should get the same data. Now, originally I had a scale of 100. I'm actually going to back this up, and it's not going to let me because of where I am. So we're going to do 100. That's fine, and I'm not going to gzip this. We were playing earlier, and this actually happened so quickly on our instance that it was being a little bit wonky. So if I generate this data, so you do the math. This is 4 days, 100 devices, 10-second readings. I actually didn't do the math on this. This ends up being, we'll find out in a minute, a few, probably 10 million, 20 million rows, something like that, maybe 10 million rows. So what does that data look like? So if I cat the data, and I should have done a little less on that, bad on my part. You can see what it is. It's a CSV-like file. right? So it generally is CSV depending on the actual database being used. It could generate a different format, and just wanted you to see what that does. So how big is that? Let's see. So the file itself for just that data is, if I do the math, it's about 5 gigs, right? So it's not small, right? It does require some space, and you'd have to know what that is. You can see I did this a little bit earlier. So zipped up, it does save a significant amount of space. It's about 400 megs. So knowing what that is, that allows you to kind of figure out. And as 𝗥𝗲𝗃 said, if I were to increase this to, if I were to do this at maybe even 1,000, so I increase this by 10, which maybe I'll do that real quick. And I'll say 1,000. So this is going to take a little bit longer. And depending on the scale, it can take quite a bit. So now, do you have something to say?
Yeah, I was saying it will be just 50 gigs. Yeah, so.
Yeah, so it will take a little bit longer. We'll get more data. So we don't generally do a scale like this at that many days. And so that's why you'll see the issue as I go. I might just stop this so that we can import. The nice thing here is, and that's why I did want to generate a little bit more data, is what can happen then is as you're ingesting, we'll give you statistics over how fast it is inserting the data and go from there. So I'm going to let this run for just, there we go. So we're done. So let's see if that ends up being about it. And there you go. It's 56 gigs. All right. So I generate a lot more data than we normally do. 3 days with 10-second readings. Maybe I'm backwards. That was only 500 meg, I think. I think I'm not reading that correctly. I think it was only 500 megs. We're at 5 gigs now.
You can add like ls minus lah.
I also get about h. You're right. Yeah. So it was 500 megs, and now it's 5 gigs, which makes sense. So if we were to go to 31 days, we should expect, I think, like I said, it's about 27, 28 megs, something of that nature. I forget exactly what, with 100, right? So, all right. So now we have the data. We can go ahead and insert it. So we have Timescale running. And so I'm going to go ahead and insert this data. And you're going to see it's an internal environment. You're going to see the password because it is what it is. We're going to talk about another way you can do this in just a minute. But this is the command itself. And I'm going to, it's going to give me an error because I don't, oh, sorry, this is that file. Okay, so let me explain what's happening and then I'll redo this. So that was the very first file I did with 100 devices over 4 days, 10 seconds. So it generated 25 million rows of data. And you can see that for this instance with 8 workers, it did 500 some thousand rows per second into Timescale DB. Pretty good. Now, obviously, cardinality is low, things of that nature. So here's what all of these options are that matter. And these go into, we go into depth in this in that, in the, here in loading data, all right? So insert write performance, we talk about the load tool and the various things you can use. The couple big ones are for Timescale, and so this is where you have to look at each database. For Timescale, we give you some options, for instance, of the chunk size to generate when you create your hypertable. So when the benchmark runs, if it's set up to generate the table, it will basically drop the database, drop the tables from the database, recreate the tables, create a hypertable out of it, and then if you provide a chunk time, it will change from the default, and the default chunk time in Timescale is 1 week. And so in this case, I generated a table, and I'm going to clear this and go up. So I generated a table, a database that had 8 hours. It didn't have anything, so it's a 1 week chunk, right? I didn't change it. I used 8 workers. So this is Go, and so this basically provides 8 separate workers to read chunks out of that file as fast as possible. And then you can do things like, do create database will recreate that table every time. This is an interesting way to change, maybe you change the number of workers. If we increase and we can say is it batch size? I always forget. I think it's batch size, and we can say 10,000. So if we do 10,000 and we were to redo this, it will basically increase this, and we could see, does that impact the speed at which it went up? And looks like this actually went up just a little bit. I could do a batch size of 10, and that's probably going to go a little bit slower because we're doing more transactions. You actually see this now by changing that batch size, it is literally taking longer. Something we talk about in Timescale, and it's something we talk about in almost every time series database. Generally, inserting more rows at once to some threshold will perform better than inserting one row at a time or a small number of rows at a time. So this is a great way to use even something as simple as inserting data. You can change some of these settings, and there's a lot of settings for Timescale. Different databases have provided other settings. You can see immediately simply changing that batch size dramatically impacted the overall rate. It's 5 times slower by doing very small amounts of insert. So that's one way that you can use just the load data into Timescale and using this feature, the TSBS load functionality. Anything you want to add, Jonas?
I also like to just highlight the importance of generating the data in advance. Like you see that we can run several tests over the same data, while if we go and just like try to generate the data live, it will just delay everything. So as everything delays when you are benchmarking, just be aware of generating files in advance is a good choice.
I muted myself and I didn't unmute. Wasn't that fun? So I'm realizing, for those of you who might be joining the stream late, this is the first time we've done a stream with both people. We tested earlier. One of the issues is I don't have my headphones here and I can't find them immediately. And so when I have Jonas playing through our streaming software, as I'm talking, we get some feedback. So I muted myself and forgot to unmute. What I'm showing here, Jonas was talking about iterations of OBS, iterations of testing a database. We provide another way to configure your specifically your data loads. And that is through a YAML file that you can preset all of your configurations for the database ahead of time. And then you could just reference maybe a different file. So there's 2 ways you can load data. You can do it through a file, or you can, and we provide another option, another sample here. Sorry about that. Which is a simulator. So that's what Jonas was talking about. We can generate data on the fly through a simulator, and you basically provide similar values to what you do to pre-generating the data. What is the scale? How often do you want a record to be generated? What are the start and end dates? And when you provide that and you run the simulator mode, we will just generate the data on the fly. Now, this is convenient when maybe you don't have a lot of space, or you want something to run for a very long period of time to generate maybe billions of rows of data, right? That's definitely possible with TSBS. If you were to pre-generate that data, it could be terabytes in size, and that just probably isn't very realistic for you. And so the one disadvantage of the simulator, because it's a Go program and because of resources, is you end up with a little bit of contention. So you will not get your fastest ingest using the simulator mode on any of the databases because it has to generate the data and use the same resources then to connect and insert that data, and it's doing everything in memory and so forth. So just recognize it. There are two ways to do this. Often if I want to just test a lot of data, I'm testing compression maybe, or I'm testing data retention, I'll set up TSBS to run for months. The time period of data it's generating is months, and that might be billions of rows of data, but I don't generate it ahead of time. Number one, it takes a lot of disk space, and number two, I might wait hours for that data to be generated to a file, and so that wasn't very helpful for anybody, right? So that is the second way you can do it. So if you use the YAML file, all of these options are available within the command line as well. But if you do that, when you load data, so I used, you can say TSBS load timescale db, and then you can say load. You have to name the database that you're ingesting, and then you can just reference the config file, whatever that config file is. And then we'll take all the settings from there. You don't have to do the command line switches on the command line. And again, this works for, if you're doing TSBS, you don't need to say load TSBS. We have allowed you now, there's just a TSBS load command, which accepts a parameter of which database you want to load. So you don't have to reference each individual load binary, all right? So those are the configuration parameters. Again, look at each database. I'm going to go back here to Timescale and just show you. When you load, you look at the database specific, and I'll go into Timescale. And we, as well as community members, really try to keep this up to date. So you'll see lots of additional flags, what they mean. For instance, the in-table partition flag, what that's useful for. Hypertable related things. So these are all available to you when you insert data, and we'll try and tell you what they do here. All right. For instance, replication factor, that assumes that you are loading into a multi-node timescale DB. If you try and do this on a single node, you'll get an error because we try and set up a distributed hypertable, and if you don't have a multi-node setup, you can't set up a distributed hypertable. So read the docs to figure out other ways that you can modify the loading process to get data in. All right, so as a marker, that's how we load the data. And you'll see then what happens. We then spit out at the very end. As we're going, you can configure how often these rows are spit out. And this just gives you a general overview of what's happening. There's been a community contribution recently, which will go in soon, that you can actually spit these results out to a JSON file at the end. The overall values, it doesn't do row by row. And then when the loading process is done, however long it takes, there will always be a summary section at the end. And this just clearly shows you how long it took, how many workers were running, and the basic metrics and rows. Now again, when we're doing CPU only, it's a factor of 10 because there's 10 columns. That's how many metrics you'll always get. These would be these would be different by a factor of 10, right? 1.1 million metrics per second, 114,000 rows per second, based on that. This was the batch size of 10 rows per, all right? All right, so now we've generated data. We want to actually be able to query that data. So this is the loading, this is the great, how does it actually work in practice? This is actually running the queries. And so I just want to talk briefly about that. When you go to TSBS and you look at the docs, give me a second. You will see at the very end, we describe all of the current current queries that we have provided and what other databases then provide within their system, so that we can try and benchmark apples to apples. And so at the very bottom under the appendix, you'll see the query types, and this is for DevOps and CPU only, and you'll see the same thing for IoT. Now, when you generate this data, it puts it into it's kind of a binary format, but it's actually text that you can see. So you can't take that file and just run it. You do have to run it through TSBS, but you can see the queries that are generated. And let me quickly talk about the difference here in what's currently implemented. With DevOps and TSBS, we try and show you exactly what's going to happen with each of these. We have group buys, one and multiple, and one host every 5 minutes for 12 hours, 8 hosts every 5 minutes for 1 hour. These are your time buckets and how many hosts we're trying to query. And so this is actually doing random queries. If I say generate 1,000 queries, which you'll see in a second, every query has a different time range and a random set of hosts when we specify hosts. So in this case, we're specifying 5 metrics and 8 hosts. So TSBS will randomly pick 5 hosts. It will create a query for those 5 hosts for some random 1 hour time range within your time range. And it will randomly do that 1,000 times. So you get queries all over your data range. Other cases, for instance, when we say, high CPU all, it literally does a query for all of your hosts, the highest CPU within your time range, and I'd have to look and see exactly which is which. So the nice thing about the the DevOps CPU only use case is it actually is trying to query more like an application. It's not just everything. It's choosing random bits of time. Within Timescale and within other databases, that really matters, right? If you are querying only recent data, some databases will have some advantage. If you're only querying historical data, other databases might have an advantage. So we're trying to just make things a little bit more random to get an idea across the board what that looks like. Now, you could generate a set of queries for a specific smaller time range and a different set of queries for a different time range, maybe to test things like historical data and recent data. You have the control, but at least you should recognize that you'll get those random time ranges and random hosts. Currently, the IoT use case, because it's kind of in process, we started this 2 years ago. Honestly, things got pretty busy here at Timescale, and we haven't done a lot more with it. This actually queries all of your data. It's basically fetching all of these things across the entire time range. And so this actually gets pretty slow pretty quickly. If you're doing a month of data for 10,000 trucks, that could be, hundreds of millions or billions of rows of data, and you're trying to find, every truck's low fuel when it was less than 10%. You literally have to scan the whole table over and over again. That's just what has to happen unless you have other things. So this does not actually take any date ranges into account. So this is not the right use case when you're trying to do that very random data. And that is why currently we use the CPU only to do the queries and so forth. So hopefully that's helpful to get a brief, basic understanding. So let's generate a query. So we provide then another option, TSBS generate queries. So for the sake of this demo, I'm going to create 3. So we provide this example in the documentation. And you know what? I'm not going to be able to do that because it's going to give me an error. Yeah. I don't know where that one is. I forgot to look, and that is my fault. So I'm going to generate 1 for the moment, and we're getting close to time anyway. So you can look at these as we go. So I'm going to generate a query, CPU only, so that Timescale knows which one you're generating for. If you used a seed, you want to use the same seed here because it will determine host names and truck names and so forth. You want to use the same scale, right? So if I generated something for 100 things, when we select random devices, we need to know how many we generated the data for. So that needs to be the same. The time range should be the same time range or at least similar time range, right? If I generate queries for totally different time range, there's no data, you'll get no value out of it. And then the couple big things are these last ones. Generate queries. So how many queries do you want us to generate? In this case, we're going to generate 1,000 queries. So we're randomly going to generate 1,000 queries for the last point query type. That is the most recent value for, I think, every host. In this case, I don't think we randomly select hosts. And then what format? So this is the database that you are testing. And so we'll generate it separately. So let me generate that one. And tell you what I'm not going to do. I'm not going to do gzip on it so that you can see what it is. So that was super quick. We generated 1,000, and I'm going to all right, there's our last point. So this is what it looks like. All right, it is a binary file because we encode a few things into this. But you can, if you're careful, you can see what the actual query is. So in this case, for Timescale, we have a select distinct on, and it comes all the way down to where we're ordering by something descending. All right. So that is our query. ฎžonatas, have you anything specifically when it comes to number of queries, things you've been testing, particularly on large and small instances, things of that nature?
Yeah, so just one small reminder that when you load the data, for example, let's say if you have larger time intervals, it will end up like collecting less data, so it will cross through less points. So it will always be fast carries with larger intervals, and then like just to be keep in mind, for example, like we have this do create DB option that like sometimes we use it to start appending data. So and maybe you mess with this appending data with different intervals, so you get like random fast results and random very slow results because the cardinality of the internal data. Just this is something that sometimes we end up like beating the head and trying to see what's going on, and that is more about like the full cycle that was not very well elaborated. So just keep in mind to like recycle the database if you are testing is always the best option to have like more accurate results, and especially when queries are random. So
yeah, that's a really great point. And so what we will do, and you'll see this in the next stream, and ฎžonatas will probably drive that one. We've spent a lot of time recently, specifically ฎžonatas and I have been working together a lot on benchmarking, and we've developed a number of scripts that we will actually share and eventually contribute back into TSBS to really allow us to, we sometimes will let a benchmarking run happen for hours overnight, and we'll set it up in a way that will do multiple different cardinalities, and the script will then generate the data, insert the data, run the query, save the results, then go to the next one, drop everything. Now we're up to a different cardinality, a different time range, different queries, so that we can see how it performs over a long period of time. But it just, as you would expect, it works a little bit better to make sure things get cleaned up. We start fresh, we insert new data, and we go for it again. And so that's one thing that we've been working through. All right. So last, let's go ahead and run some queries. I think that we still have that set as my marker, so we're running queries here. So let's see what that looks like. Oh, you know what? I forgot to grab that one out, so let's go back here. So how to actually run queries. Load the data. Sorry about that. All right, so here's a quick example. And I probably have a different one somewhere else, but we'll do this one. So in this case, again, we're not going to have to gzip this in anything, but we'll go ahead and give this a quick run. This is what live coding is for. It's probably going to give me an issue there. So you're going to go ahead and see, as you did earlier, how to load. So our host is, do you have that off the top of your head? And if not, I can, we're going to have an issue there. Okay. So what is it?
100,043, as far as I remember.
All right, and our user is Timescale, and all right, and we can do that.
Yeah, it's sorry, it's 10,243.
Okay. And again, same thing here then is we can determine how many workers to run. So this kind of mimics, and I'm going to get this where you're not going through gzip. And so you can see here, I'm going to go back to, this is in the temp directory. So I'm going to say timescale and queries, and there's my last point. So this is 1,000 of the last point SQL query running against this database. We're running the timescale version. We're using 8 parallel workers. So they're going to each grab a query, run it, log the results, and they're going to keep going until all 1,000 queries have been run. And by default, it will report at 25% as you go. So 25%, 50%, 75%, and 100%. So in this case, every 250 queries, we'll get an example of what's happening as we go. Then I probably also have to, this is going to give me an issue, I'm guessing. Do I have this? Oh, my, sorry about that. I missed the pipe.
Right? Yeah.
Sorry about that.
I was just confirming the options we have while running.
Yeah, so for this one, okay, so
It does not get the Postgres there, the Postgres URI. I see the promise is a bit different. You need to say minus hosts because you can
Yep.
run against several hosts, not only one. So, but it's like a Postgres string of additional connection parameters. This minus Postgres is just to say SSL mode
Right.
disabled, for example.
Right.
So you need to say minus port, minus pass, and minus hosts. And yeah.
oh, what is fast? Port is 5432 because again we're on an internal network that no one can get to. And then I think we have to actually, is it database? In this case, it might be benchmark. Let's see what happens. All right, so DB name. Port, so this is nice, right? We get the, that's a string. I think host is a string, so that was my issue there. This is live coding. I forgot to.
Hey. Yeah, it says host. It's hosts.
It's hosts, isn't it?
Yeah, it's multiple hosts. I don't know why, but yeah.
All right, so my guess is user Postgres, so I also need user.
User is Postgres.
And for us, our user was Timescale for this database. All right, so that happened super fast. So this ran 1,000 queries, and we can see that in general, now we recognize this is, I think, only 25 million rows. Not a lot of data. It's only over 4 days, and it's only for 100 devices. So this got the last point reading for 100 devices 1,000 times, essentially. And it basically ran 4,700 queries per second in total. And so that is how you can generate, you can query lots of stuff. Now you can do other things. I say we can see what happens when we have fewer workers. So now if I only do one worker, you'll see it does go a little bit more slowly, right? It's one worker peeling off 1,000 queries, running it against the database and coming back. So this is, again, another way that you can take some of these sample queries and see what happens. Now, if I were to say, maybe I'll do 100 workers. And some of this depends on the amount of resources on the client you have. And again, now we're going back and forth. At 8 workers, we were at 4,700 queries per second. At 100 workers, for this query, the database still performs honestly pretty well. And we're at 3,500 queries per second. What we currently spit out along that path are the min and max within that time range. So this is, you can see that it's happening after every 100 queries. Within that range, what is the current min and max and mean and median and standard deviation and so forth. And then the very last one will always be the overall average at the end of the whole process. And so this is what you can use, and this is what we will grab. So we'll typically use the mean, which is the average. If we use something different, we talk about it in the article. You know, having standard deviation, it's actually kind of funny. If you haven't seen today, we have a pretty great article about percentiles. And it's something that David Cohn wrote. He's part of our team. It's really hit a nerve with a lot of people about percentiles. It's been on Hacker News for almost a whole day already. And so, you know, you can decide what makes sense within your range. You know, the median would be the 50th percentile. I think that we've talked about giving the option maybe of adding in some new things, so doing like a P95, something of that nature, because that could be really helpful in your environment. Maybe the P95 is still 6 or 10 milliseconds, but your average is a second. And so you can see that your database has some load issues, but it's a really small fraction of the queries that are actually running. And so again, you have to decide what the load is, how you want it to work. We're really about out of time. I'm going to unmute ฎžonatas in a second. I can hear you, ฎžonatas. Everyone else can't. Is there another query you think we should run real quick? I'll generate it quickly. Anything come to mind?
I was just going to just share like how advanced is this tool. For example, we have a minus burn in.
Tell you what, let me unmute you and go ahead and share what you want to share.
Okay. Okay, one more interesting detail about how advanced this TSBS. You can also use a minus burn in to just create like a warm-up moment, so you ignore the results of the first query, so while you are like hitting the caches and everything. So it's very cool. You can check out the options. You see that a lot of different options are available, and probably exploring them independently will give you more insights than just trying everything at once. So
that's a great point. So tell you what, I just do one more just to show how this is different. So the last point in Timescale DB is honestly a really strong, really great query, and it's something that almost all time series databases should be able to do well. And I'm just going to call it a single, even though it's a specific one of these singles. So last point is finding the most recent reading of everything in your system, right? And so back in Timescale DB 2.3 specifically, we introduced a feature called skip scan, which makes that very efficient and is really an area that, because of indexes within a Postgres database, an area where we really excel and really common, right? If you're measuring IoT devices, you often need to know what the last reading was. And so it's just a really, it's good demonstration how quick it can be in your environment. So I just generated 1,000 queries of the single group by, and the single group by of the description is, we're going to get the max for one metric for one host every 5 minutes for 1 hour. So we basically do a time bucket 5 minutes, a time range of 1 hour for one host. And that's what this signifies. And so you'll see that it performs differently. So I'll do the, so I called that one single. And I'm going to take this back to 8 workers just to, I don't know, maybe I'll do 16. Yeah, that was actually still pretty fast. And again, we have 100 hosts. This is not going to be a very heavy data set. That wasn't the intent of this specific stream. We just want to show you how to use it. But again, so you see each one performs a little bit differently as you get to maybe the high or the max CPU within a time range. That means you have to maybe scan different chunks and so forth. So those are the basics. You can download and install Timescale, TSBS. You can generate data or do it on the fly. Remember, we showed you those YAML files, or how you can do it from the command line. It shows you in the steps. Once you generate the data or you do it in simulated mode, you then load the data into your database. That will measure the rate at which it is loading. And I'll caution you again that what we talked about there is, if you use the new simulator feature, if the database supports simulator, and to be honest, I'm not sure all of them do at the moment. It's been a while since I've looked. We'll have to look at that for next time. You will incur a performance overhead, some kind of overhead with TSBS generating the data as it tries to insert it. And so you will almost never get the best ingestion rate by using simulated mode, but it's really helpful when you want to just generate lots of data to do some other kind of testing, like query testing. Or in Timescale's case, it's really useful when you want to test compression or data retention, or even continuous aggregates, continuous aggregates that are generating data over and over again at a timed interval. So that can be really useful. You don't care how fast it really goes in. You just want lots of data. That can be really useful for that. Once the data is in, you then generate the queries. You can scale how many queries you want, the types of queries we provide, which are listed at the bottom of the GitHub project. And then finally, you can run those queries one at a time against the database to see how the database performs with that specific query form, right? So order bys will work differently in some databases than others. Finding, as I said, something like the most recent value will work very different in something like Timescale as opposed to maybe Influx or something like that. And it's partially due to the data structure. So that's the basics of this stream, where we wanted to get to give you, have a video on record of how to do the basic operations. What we're going to do from this point is we'll schedule these soon. We will basically have a stream that then digs into a more full-featured benchmark of Timescale. We'll show you some of the scripts that we've written to help us do that on our own. We'll let it run. It will probably be longer than an hour. We'll let that run to show you, a database under load, what happens with 4,000 hosts versus 10,000 hosts, different time ranges and so forth, how maybe a couple different queries perform, the things you can learn from that. And then we will eventually actually benchmark two databases together, so Timescale DB and a different database, one we've been working on recently for us to better understand features. How do things like compression in Timescale DB impact your querying, for instance? It turns out in most cases, it actually makes your queries run much faster, and it's something most people don't know about Timescale DB. Don't really understand, the value that can bring aside from just saving space. So hopefully this has been helpful as a good primer into TSBS, something we'll have available online for other people to use. Jon-Tas, any last words you want to add in? I just want to unmute you.
No, I think that's it. I really like to be here and participate of this first session, and looking forward to explore more of TSBS.
Sounds great. And for our next dual stream, I'm just going to have to make sure I have my headphones and fix the audio issue. So apologize for that at the beginning. And thank you, Jon-Tas, for being understanding of the muting and unmuting. It's good stuff. So thank you so much. Have a great day. Thanks for taking part in our stream, and let us know if we can help you. Always reach out to Slack if you need us. We have a great community on Slack. You go to Slack. I honestly forgot to put this in at the last slide, so that is my fault, but slack.timescale.com. And my computer is being very, very happy right now. This will get you to the sign up if you are not part of our Slack channel. Please do that. Jon-Tas and I and all the other dev advocates are in there often. Other people from the company are in there as frequently as we can be. We have a great community manager that's watching things for us. It's a really good place to come and help, get some help and contribute back to this project and others. So thanks so much. Have a great day.